The initial basic feasible solution of a transportation problem obtained using the least cost method is shown on the left. We are going to use the stepping stone method to find the optimal solution. Start by identifying all the unoccupied cells, which are these ones. Beginning at this cell, which is F2A, trace a closed path back to the original cell via the squares that are currently occupied. Note, only horizontal or vertical moves are allowed. Begin by moving horizontally to the right, vertically upwards, horizontally to the left, and then back to the original cell. Beginning at this cell, place a positive sign, and then place alternate signs at each corner of the traced path. In this case, we place a negative sign in this cell, a positive sign in this one, and a negative sign in the last cell. We move on to calculate the net change. This we do by adding together the unit cost figures found in each cell containing a positive, and then subtracting the unit cost in each cell containing a negative sign. In this case, it's 12 minus 8 plus 20 minus 14. And that will give us a net change of 10. Moving on to cell F2B, which is this one, we will trace a closed path from this cell back to the original through the occupied cells. In this case, we'll move horizontally to this cell, vertically to the next cell, horizontally back, and vertically down to the original cell. Begin with a positive sign in this cell, a negative sign here, positive, and negative. We move on to calculate the net change. 14 minus 8 plus 20 minus 16 to give a net change of 10. Moving on to the next unoccupied cell, which is F2C, which is this one. We trace a closed path back to the original cell. In this case, move horizontally to this cell, vertically upwards, horizontally to this one, and back to the original cell. Place a positive sign in the original cell, negative sign in this one, positive, and negative. The next step is to calculate the net change. In this case, it's 10 minus 8 plus 20 minus 12. This will give us a net change of 10. We move on to the next unoccupied cell, which is F3A. F3A is this one. Trace our closed path back to the original cell. In this case, we are going to move horizontally to this cell, vertically to this one, horizontally to this cell, and back to our original cell. Start by placing a positive sign in the original cell, which is this one, negative sign in this one, positive, and negative. Move on to calculate the net change. To calculate the net change, we're going to add 10, subtract 8, add 12, subtract 14, and that will give us a net change of 0. We move on to the next unoccupied cell, which is F3B. F3B is this cell here. We trace a closed path back to the original cell. In this case, we are going to move horizontally to this cell, vertically to this one, horizontally, and back to the original. Place a positive sign in the original cell, negative sign, positive, and negative. Calculate the net change. 16 minus 8 plus 12 minus 16. This will give us a net change of 4. Moving on to the last cell, which is F3D. Trace a closed path back to this cell. In this case, we are going to move vertically upwards, horizontally to this cell, vertically downwards, and horizontally back to the original. Place a positive sign in this cell, negative sign, positive, and negative. Calculate the net change. 15 minus 20 plus 12 minus 8, and this will give us a net change of -1. We have now looked at all the unoccupied cells. However, this one is less than 0, therefore the solution is not optimal. Since the solution is not optimal, I move on to the next step. Allocate as much as possible to the cell with the most negative net change, which is this cell. Compare the two allocations in the cells where there are negative signs. In this case, we are comparing 15 and 60. The minimum of these two values is 15. Add this 15 to the cells with a positive sign and subtract it from the cells with a negative sign. In this case, we add 15 to 0 since there was no allocation in this cell to give us a 15. 15 plus 5 will give us a 20, so we remove this 5 and we put the 20 allocations. Next, we subtract this 15 from the cells where there are negative signs. 15 minus 15 will give us 0. So in this case, these 15 units will go away and we were left with no allocation. 60 minus 15 will give us 45. So we remove these 60 units and put the 45 units. Then we go on to calculate the net changes for all the unoccupied cells. We will start with cell F1D, which is this cell right here. We trace a closed path back to the original cell through the cells that are already occupied. In this case, we move horizontally to this cell, vertically downwards, horizontally to this one, and vertically back to the original cell. Place a positive sign in this cell, negative, positive, and negative. We move on to calculate the net change. In this case, it's 20 minus 12 plus 8 minus 15. This will give us a net change of 1. We move on to the next unoccupied cell, which is F2A. Again, we trace a closed path back to the original cell via the cells that are occupied. We move horizontally to this cell, vertically downwards, horizontally to the next cell, vertically up, horizontally to this one, and back to the original cell. Again, we have to place a positive sign in the original cell, negative sign, positive, negative, positive, and negative. Then we move on to calculate the net change. The net change in this case would be 12 minus 8 plus 15 minus 8 plus 12 minus 14. This will give us a 9. We move on to the next unoccupied cell, which is F2B. Trace a closed path back to the original square through the cells that are already occupied. In this case, we are going to move from this original cell horizontally to this one, vertically to this cell, horizontally to this one, vertically upwards, then horizontally to this cell, and back to the original square. Place a positive sign in this square, negative sign, positive, negative, positive, and negative. Then we calculate the net change. In this case, it's 14 minus 8 plus 15 minus 8 plus 12 minus 16. This will give us a net change of 9. Moving on to the next unoccupied cell, which is F2C. Beginning at this cell, we have to trace a closed path back to the original cell. In this case, I choose to move horizontally to this cell, vertically downwards, horizontally to this cell, and back to the original cell. After this, We place a positive sign in the original cell, negative, positive, and negative sign. Then I move on to calculate the net change. In this case, it is 10 minus 8 plus 15 minus 8. This will give us a net change of 9. We move on to the next unoccupied cell, which is F3A. Again, we trace a closed path back to the original cell through the cells that are already occupied. I will move horizontally to this cell, vertically upwards, horizontally to this one, and back to the original cell. I place a positive sign in the original cell, a negative sign here, positive and negative. Moving on to calculate the net change. In this case, it will be 10 minus 8 plus 12 minus 14. This will give us a net change of 0. Moving on to the next unoccupied cell, which is F3B. Trace a closed path back to the original cell. In this case, I will move from the original cell to this cell, and vertically upwards to this cell, horizontally to this one, and vertically downwards to the original cell. We'll begin with a positive sign in the original cell, negative, positive, negative. And now we calculate the net change. In this case, we have 16 minus 8 plus 12 minus 16. This will give us a net change of 4. In this case, all these values are greater than or equal to 0. So this means we have reached the optimal solution. I go on to interpret. From F1 to A, we have allocated 30 units at a unit cost of 14. 30 times 14 will give us 420. From F1 to B, we have allocated 50 units at a unit cost of 16. 50 times 16 will give us 800. From F1 to C, we have allocated 20 units at a unit cost of 12. 20 times 12 will give us 240. From F2 to D, we have allocated 40 units at a unit cost of 8. 40 times 8 will give us a cost of 320. From F3 to C, we have allocated 45 units at a unit cost of 8. 45 times 8 will give us a cost of 360. From F3 to D, we have allocated 15 units at a unit cost of 15. 15 times 15 will give us 225. The total of these costs will come to 2,365. Thank you for watching.